Math 1332, Chapter 10, Probability and Counting Techniques, Section 6, Odds and Expectation, Video 2, Converting from Probability to Odds. In the previous video, we learned how to calculate the odds in favor of an outcome and the odds against an outcome. Just a reminder, odds in favor of an outcome is the ratio of successes to failures, the number of ways for an experiment to have a successful or a desired outcome, compared to the number of ways for an experiment to have an unsuccessful outcome, aka a failure. But odds against an outcome simply mentions the failures first. Against is failures to successes, in favor of is successes to failures. Like fractions, odds can be reduced. For example, suppose a bag contains 10 blue marbles and 5 red marbles. Here's a very crude drawing of that. Round bag, 10 blue marbles, 5 red marbles. The odds in favor of drawing a blue marble are 10 to 5 because there are 10 ways to successfully draw a blue marble and 5 ways to unsuccessfully draw a blue marble. D reduces by 5 to give 2 to 1. That's crazy. That's going to get fixed right now. Again, I know this isn't something that I have to do a screen share with, but I am human, and when I make mistakes, I don't mind fessing up to them. And if I can just get this to cooperate. This reduces by 5 to give 2 to 1. That sounds good. All right, let's resume the slideshow and make sure that you can see the slideshow. All right, so let's backtrack and say this again. All right, so like fractions, odds can be reduced. For example, suppose a bag contains 10 blue marbles and 5 red marbles. Crude illustration. What are the odds of drawing a blue marble? The odds in favor of drawing a blue marble are 10 to 5. This reduces by 5 to give us, sorry, I got something obstructing my view, to give us 2 to 1. All right. Shrink this down. Why is that not disappearing? Okay, sorry, Zoom issues. Now, one of the problems with odds is that people frequently confuse them with probability. I see this all the time. I see it in the media. I see it in literature. I see it in casual conversation. People don't know the difference between probability and odds. Now, to show you this, ask someone, or to see it for yourself, ask someone, and I'll ask you right now, what is the probability of flipping a coin and getting heads? What is that probability? Now, there's a good chance that you or somebody else is going to say it's 50-50. But is that really a probability? Well, they say that because they expect heads 50% of the times and tails 50% of the times. But if we're looking for the odds in favor of flipping a coin and getting heads, excuse me, we're asking for the probability. Well, so what's the confusion? These are odds. Why is 50-50 odds? Well, think about what the 50s represent. 50-50 is a comparison of successes to failures. Go back a slide. When you say 50-50, you're saying 50% of the times it succeeds and 50% of the times it fails. So you're literally comparing successes to failures, which is the definition of odds in favor of an event. And if you notice, the odds reduced to 1 to 1 because I can divide both numbers by 50. So the odds of getting heads is 1 to 1. And more specifically, the odds in favor of getting heads is 1 to 1. And you may have noticed that a lot of times I will say the odds of instead of the odds in favor of. That is fairly common. I will try to be a little bit more consistent with saying in favor of. But if I just say the odds of, you can assume it means odds in favor of, because the other one will always be the odds against. So the odds of getting heads is 1 to 1. So what is the probability of flipping a coin and getting heads? Well, there's 2 possible outcomes when you flip a coin, heads and tails. Now, only one of them is a success, which we've defined in this example as flipping heads, that one. So the probability of getting heads is 1/2, or 1 out of 2, or 50%, because There is one successful outcome out of two total outcomes. Remember, probability is the ratio of successful outcomes to total outcomes. So 1 out of 2 total times we would expect to get heads. Odds is a comparison of successes to failures. For every 1 time we get heads, we expect 1 time to not get heads. Let's look a little bit more closely at the odds in favor of flipping heads and the probability of flipping heads. The odds in favor of heads is 1 to 1. The probability of heads is 1/2. Now let's insert what each of these numbers represents. Here are the odds and probability. And remember that odds in favor of is successes to failures. Probability is successes to total. So when I say 1 to 1 on the odds, I'm saying 1 success for every 1 failure. When I'm saying 1/2 for the probability, I'm saying 1 success out of 2 total outcomes. Now, probability, let me back up for a second. We're trying to figure out how to convert probability to odds. So we will start with the probability and we want to end with odds. So we have to ask ourselves, when we're given a probability, what information are we given? But what information do we need to calculate odds? Probability gives us numbers for successes in total. 1 success out of 2 total outcomes. But odds need numbers for successes and failures. You have to pardon me. The word odds sounds plural, is singular. So sometimes the verb may sound a little bit funny. Odds needs numbers, odds need numbers, but I digress. Probability gives us numbers for successes in total, but odds need numbers for successes and failures. Now this begs the question. If you know successes and totals, because that's what we know when we're given probability, how do we calculate failures? It's actually pretty easy, because we've done it already. In the previous video with the Scrabble tiles, I remember we had 100 tiles. We took away the 9 successes. We got 91 failures. Successes plus failures equals total. But if you do a little bit of algebra, you can rearrange it to say failures equals total minus successes. So if we're given a probability, we are given totals and successes, which means we can do this subtraction problem, which means we can calculate failures, which means we can calculate odds because we'll have successes already. So this gives us the following strategy for converting probability to odds. Now, for those of you that like algorithmic processes, step 1, step 2, step 3, here it comes. How to convert from probability to odds. Step 1. Remember, you're given a probability. Assign the numerator of the probability as the number of successes and the denominator as the total number of outcomes. Then calculate the number of failures by subtracting total minus successes. This will give us enough information to calculate the desired odds or form the desired odds. Odds in favor is the ratio of successes to failures. Odds against is the ratio of failures to successes. Again, this is a good algorithm to convert probability to odds. 3 simple steps. Just remember the following. Probability is the ratio of successes to total. That's what we're given. Odds in favor of is ratio of successes to failures. Odds against is ratio of failures to successes. But regardless of which one we're building, we need to know the number of failures. And successes plus failures is equal to the total number of outcomes, or failures is the total number of outcomes minus the successes. Let's take a look at a quick example. A teacher selects a random student from a class. The probability of selecting a male student is 13 out of 25. Okay. 13 out of the 25 students are males. Number 1, what are the odds in favor of selecting a male student? And number 2, what are the odds against selecting a male student? It should be pretty obvious that once we answer number 1, we can answer number 2 by simply taking the reciprocal. So let's focus on finding the odds in favor of selecting a male student by following our process. The first step in our strategy is to convert probability to odds is to assign the numerator of the probability as the number of successes and the denominator as the number of outcomes. Now, since we were told that the probability of selecting a male is 13 out of 25, we assign the following values. The numerator represents the number of successes, so that's 13. And the denominator represents the total number of outcomes. That's 25. Step 1 is done. Successes, 13 of them. Total outcomes, 25 of them. The second step in our strategy to convert probability to odds is to calculate the number of failures by subtracting total minus successes. Fairly straightforward. Since we have 13 successes and 25 total outcomes, the number of failures is 25 minus 13 is equal to 12. So now we have 13 successes out of 25 total outcomes, giving us 12 failures. And then the final step in our strategy is to convert probability to the final step in our strategy to convert probability to odds is to form the desired odds. Odds in favor is the ratio of successes to failures. Odds against is the ratio of failures to successes. So the odds in favor of selecting a male student are 13 to 12, and the odds against selecting a male student are 12 to 13. Just remember the following, and you should be able to easily convert from probability to odds. Probability is the ratio of successes to total. Odds in favor is the ratio of successes to failures, where odds against is the ratio of failures to successes. And the relationship between the three is that successes plus failures is equal to total, or failures is equal to total minus successes. Now, this is the last slide, but I realized it was something I left off of this, and I think it's worth mentioning because probability doesn't always have to be given as a fraction. For example, you could say the probability it's going to rain outside is 80%, but that's not a fraction, that's a percent. So I want to take just a brief moment to open up a whiteboard and show you what to do if the probability is given to you not as a fraction, but as a percent. Now, I don't like this Zoom whiteboard. It used to be my favorite thing till they updated it. But let's just say we were doing a problem that went something like this. If the probability, let me make this font size a little bit larger. Let's take it up to 36. If the probability that it will rain is 80%, what are the odds in favor of rain? Now we could also say, and the odds against, but by now you should know that all we have to do is take the reciprocal, and that'll give us the other one. See, this isn't what it used to do. It's driving me crazy. I just want to make this box wider. Why you got to be so stupid? There we go. Now, we can use our same process, but the only problem is that our probability is given as a percent. And our process is based on the assumption that the probability is given to us as a fraction. So how do we overcome that? That's easy. Same way we've done it since we've been playing with decimals, fractions, and percents back at the beginning of chapter 7 and 7.1. Let's take this back up to 36. You have to rewrite 80% as a fraction. And the way to do that is to remember that percent means per 100. Now, we could run with that. We could say 80 successes out of 100 total outcomes. Or we could reduce it, and it would reduce by a lot. It would reduce by 20. 80 divided by 20 is 4. 100 divided by 20 is 5. And what this would tell us is that we have 4 successes and 5 total outcomes. But if we want to calculate odds, we need to know the number of failures, and the number of failures is 5 minus 4, which is 1. And so the odds in favor are the ratio of successes, which is 4, to the ratio to failures, which is 1. And of course, the odds against would be 1 to 4. Had we not reduced the 80 over 100 to 4/5, this would have said 80 to 20. And at this point, we would have reduced it. All right, so thank you for letting me do a little bit of extra there, but I just wanted to mention what you would do if you were trying to convert a probability to odds, but your probability was given as a percent. The short answer is turn it into a fraction.